So I'm here to talk about enterprise considerations for when you are using AI. And a lot of the motivation for this talk comes from the fact that we go out, deploy different agents, different applications that consume models on the internet, and there's no governance wrapped around it. So there's a lack of authentication, there's a lack of systems of records, and there's just so much going on behind the scenes that we are at the phase of shadow AI. So my name is Marino Wijay. I am a solutions architect at a company called Kong. We deal in API platforms and AI management as well. I'm a CNCF ambassador. Woo, yes, you should become one if you are not, and if you like the Kubernetes ecosystem. I'm also Canadian, so I flew down here from Toronto. And I love community, I love coffee, I love containers. You can go find some more information there in that QR code, so if you want to connect with me on LinkedIn or Twitter or wherever else, you're more than welcome to. And I figured we'd start off with a demo first, because I love action before we start getting into the boring bits. So before I get into that demo, I just want to explain what's going on here. So I've got my MacBook here that runs something called Insomnia, which is a Postman-like system. It allows you to run requests against your APIs and test validation, make sure that it's working the way you expect it to, and whatnot. But what it's actually doing is it's calling out to different models, but through something called a Kong AI gateway. So how many of you are familiar with API gateways? Love it, okay. So I don't have to get into the details of that. So they just transact with your requests and forward on those requests based off of a set of conditions and policies out to your whatever endpoint that you're trying to hit or reach. In my case, we're actually using the Kong AI gateway to get to OpenAI, to get to Gemini, as well as Bedrock. So let's get into it. Quick note, I am running a Kubernetes cluster, and I just had to because it's a KCD event, so we can't not run one. And in my little cluster here, I have a 3-node setup, nothing fancy, but I'm running it on top of Civo Cloud. So if you really want to get your hands dirty with Kubernetes, go to Civo Cloud, you get some credits, you can mess around with it. And here's my cluster, it's running. And I also want to show you something where I'm actually hosting my API gateway inside of Kubernetes. Now, there are a number of different ways you can do this. I cheated and just deployed the data plane directly to Kubernetes, and I manage it in a very unique way where it pulls in a configuration from the control plane that's hosted elsewhere. The reason I did this was because obviously it takes a lot of time to build out an infrastructure that requires an operator, a set of custom resources that interact with your control plane that doesn't live locally, it lives somewhere else. So there's a lot of exchange going on and a lot of reconciliation that goes on behind the scenes. So I just did it very easy and decided, hey, let's just run Kubernetes. So I have a pod here called my Kong. It's running in the Kong namespace. That is my data plane. That is where my AI gateway lives, where I send traffic. It processes my request, and based off of a variety of conditions and policies, will send off that request to, let's say, an LLM. Now, you can also run this on Docker if you want to. If you're doing some local testing, I actually have a little link where you probably saw in the QR code there where you can just run a quick curl script and pop in your OpenAI API key, and you can also start playing around with it as well. But we also have an extensive set of documentation that gives you enough guidance on how to be able to do this for a test environment, and then if you're trying to run this at enterprise scale. All right, so I'm going to also show you a nice little client called Insomnia, and this is where I'm running a variety of different tests. So I have my control plane here. It's effectively running. I've just called up to a system called Connect, where the control plane is living. But my data plane, again, lives in a totally different environment that I own and manage and host. And I've also got a few calls out to different models here. I'm going to load balance between, I think, two models here. OpenAI's, I think, O4 Mini. I think I set up O4 Mini. And then Gemini. So when I send out this request where, let me know if you can see it all. I can make it bigger too. When I send out this request, I'm just feeding the model some context around what it's supposed to be doing, and then asking it to give me a response based off of the prompt that I send. So I just basically asked it to explain what a for loop is. And if I go ahead and send out that request, what we'll find is O4 Mini, OpenAI's model, actually responded with a rather decent amount of information. If I send the request again, now I have Gemini providing a similar answer, but also slightly different, but I'm going to a different model. Now, why you might want to do something like load balancing is you might have a situation where you're running a large-scale local model that you built and trained locally in your environment that is handling a majority of the tasks that your developers might be consuming and building out. And then there might be instances where you need to actually go out to a cloud-based hosted model. Now, the consideration here is that you're probably thinking about cost savings, you're thinking about ways that you can protect your data so that it doesn't flow outbound into a cloud provider or a hosted solution, because maybe you're also worried about PII, personally identifiable information. I've also got a Bedrock set up here as well, where if you wanted to use Amazon Bedrock and its different models, you absolutely can do so. I just asked it a basic question, what's 1 + 1? Nothing spectacular. But I want to show you that last one there. And actually, before I do, I actually mentioned that there are a number of ways you can run your data plane. So you can run it locally on Docker, you can run it in Kubernetes. You can also have it hosted. So all you do is you just point your APIs and your requests to a dedicated cloud gateway, and you don't have to worry about the managing of that infrastructure at all. Okay, so around that PII note, the one thing to consider and think about is, I'm going to give it my name. I'm going to give a model my name and my phone number. That's not my phone number. Please don't try calling it. It's not going to go anywhere. Don't text it. And what happens is I have a PII sanitizer that's also running. So I send my request to my gateway sends it to the PII sanitizer. It sanitizes the request and removes any sort of information like my name, my phone number, or replaces it with something different. In this case, when I run it, what's going to happen is it tells me that it can't process my personal information, so I'm going to run it again because I'm also load balancing to another model. And it tells me my name is now Ruth Gonzalez, and my phone number is 705-401-9124. Absolutely not. That's not me, but we know it's working. And you might do that in instances where you don't want to leak out credit card information. Maybe you also want to redact and hide your API keys for other systems that you might be consuming so that the model itself never gets access to it. If you want to play around with Insomnia more, just go to insomnia.rest. And you can download the client and start building your requests as well. Okay, back to the slide deck. And I'll leave that QR code there for one more second so that in case you wanted to get it loaded up into your system and test out the AI gateway for yourself locally on Docker, you're more than welcome to. And I also share this at the end too, so don't worry if you miss it. All right, so MCP and AI had a problem. The problem is people just consume it. People just build MCP servers. People build agents without considerations around authentication, without considerations around cost, without provenance. There's no system of record of the MCP servers that you're using, so we cannot guarantee the validity of a server, right? We just basically deploy one or we build one, and no one is providing any sort of governance around it. And then you have all of these different developers that are going out and effectively trying to consume models by just swiping their credit card. I do it. I'm guilty of it. I'm sure some of you are as well. And the whole purpose of trying to avoid that situation is so that we don't run into shadow cloud all over again, or shadow IT. This is the same problem we ran into when folks started consuming AWS and GCP freely without any sort of enterprise governance. And then you have an MCP server, and you're trying to understand what the hell that is. So an MCP server simply just takes all of what we're trying to do and provides an interface for being able to process requests. So it might have a packaging of prompts. It might have a set of tools that processes some of the data that we receive or send out to an MCP server. And then it'll also refer to maybe a subset of documentation so that it can give you additional, much more detailed information about the particular prompt that you're sending over and the information you're trying to get to. But the problem that I talked about several minutes ago are just all laid out here, right? You're using MCP without any form of governance, any form of authentication, any form of encryption, if you will, if you think about it. And one of the concerns here is that when you think about enterprise security environments or enterprise security teams, if you will, they have no awareness into what's going on. If you operate a very massive airline, chances are someone's using AI somewhere, and there's no governance around it. And so you have to protect that. You have to somehow govern it. You have to provide the guardrails. You have to rate limit, because at the same time, you also don't want teams to overconsume a model or overconsume budget. You want to set those and enforce those particular guardrails as well. You might even see things like, hey, I'm going to share a bunch of information for another customer, which I'm just like taking their question, dumping it into ChatGPT, and then off it goes into the cloud without thinking about blueprint information, names, naming conventions, policies, that just exposes another customer's information out there on the public web. So we have the AI gateway pattern. Now, an API gateway simply functions by taking in requests and wrapping policies around it. In my case, we use a plugin-like architecture where you turn on plugins as you need to enable things like authentication for, let's say, OpenID Connect. Or you want observability to be able to see where your traffic is going, how much traffic is getting to that destination, even latency for that matter. And let me tell you something, if you're thinking about latency for a second, if in your code base you are saying to generate a function or run a function for you and then return a value in that code, that's added latency to how your application performs. Because now you're at the mercy of a public model that may be overwhelmed. So there are other considerations, like if you have a team of developers that are doing roughly the same thing, you might be able to cache some of those queries and store them in a, let's say, a vector database as embeddings, and then return those cached values without having to sit there and resend that request out to the model. Oops. Okay, so how do we make this all work? So there are a set of plugins that are available to us. We have a number of different plugins in the API gateway infrastructure. The first two are the AI proxy and the AI advanced proxy. So in the AI proxy, we just provide a single API endpoint to your developers or to any agent that just consumes models. And on the back end of that proxy, we've defined a set of models like OpenAI or Gemini or even Bedrock for that matter. And in the advanced proxy settings, we have the capability to set different kinds of load balancing algorithms, and then we can load balance based off of certain conditions. Those conditions might be latency-based conditions, geo-based conditions. It might be conditions based off of context. For example, if I have let's say I have a call center, right? And I want my agents, my call center agents, to refer back to documentation, and they just need quick answers. That should be a local model that processes that information and returns it back to that agent. Whereas they don't need to be going to OpenAI all the time to get a response. And then there are other types of plugins too that transform your requests and your responses. So on the way out, by the way, this operates in an egress fashion. So your request hits the gateway and then sends it off publicly or to another model that you might be hosting locally. So you might be transforming both your requests and your responses on the way in and on the way out as well, just so that a model can understand what you're trying to ask it, or the application that you're using or you're building can understand the response that your model gives you. And then there are firewall-like plugins and capabilities as well. We are actually providing static entries where you can't ask about C++ queries, but you can totally ask about C# and Java all day, every day. But the thing is, developers are smart. They'll work their way around that, and they'll effectively navigate that prompt in such a way that prevents that prompt guard from actually working. So you have a semantic prompt guard, which caches that data, but also looks for similarities in your prompts, in your queries. So you might ask it for some C++ code, and you might be actually using C ++, whereas someone could just say, hey, give me some C++ in the full word itself, without actually using that, that wording and then effectively get a response. So that semantic prompt guard evaluates for that based off of the similarity of those requests and make sure that you effectively block them. And then maybe your developers just don't know how to effectively pass in information. So you can decorate your prompts. You can provide templates as well. Now, the templating just simply allows them to just speed up their development cycles, basically a developer experience approach, whereas the prompt decorator basically tells the model to behave in a certain way with a certain tone. Maybe you want it to be nice to your developers, or not. And then there are a few others too. So I talked about caching. Now, caching is important because you have to think about two things, your latency and then your cost as well. If you constantly send calls to a model that's publicly hosted, you're just consuming credits. Yes, your token usage might not be as much, but let's say you're running some regression tests or scale testing, and you're constantly running a bunch of curl requests against the model, against various conditions, that's just gonna chew up your credits. So rather than having that happen, you can use something like a vector database to be able to cache those entries and not have to call out to the model specifically. And then, how many of you have worked with RAG, Retrieval Augmented Generation? Okay, awesome. Maria, do you want to tell us what RAG is? Okay, so in short, it's a mechanism to prevent hallucinations because you send a request to a model, and then as it comes back as a response, you actually further process it with maybe another model, perhaps, to clean it up, to make it a lot more contextual, so that you don't experience the hallucinations and you actually experience something that's far more accurate. Because sometimes you'll ask a model something, it has the right context, but it might not have the right response. And so you need to be able to, or it might even invent things that don't even exist. Because I've seen that happen a million and one times. For some reason, it invented or it created some, I think it was I was working with Terraform once, and it created a bunch of providers that never existed. And I don't even know how it even came to be or think up something like that. So that's an example of a hallucination. And in terms of rate limiting, you might have a situation where you have to limit your developers and how much they consume, or maybe their token size as well. There's a few other things. I showed you the AI sanitizer. It's just basically scrubbing your PII as well. That's something that you deploy. We'll provide you an image. We'll provide you code for you to run it. You host it, place it wherever you need to, and it'll just forward traffic to that PII sanitizer and then effectively return redacted or jumbled information. And there's one more about Azure. I really don't know what it does, to be honest. I almost never use this one. So this is what that AI gateway pattern actually looks like. So that AI gateway pattern is the fact that you run and build agents that run inside of Kubernetes, or they could be running in Docker, or it could be running on ECS, or any kind of workload environment. And you have developers that are also consuming similar models as well. And the nice thing is you don't have to have just one single gateway. You can have multiple. They could live anywhere you want. And you can load balance across those different environments too as well. And they may be hitting an MCP server, but as they hit an MCP server, you have to throw in an authentication layer. You have to throw in rate limiting capabilities. Throw in a whole bunch of governance around that so you prevent situations like your MCP server going down. You might be building an MCP server and forget to wrap authentication around it. That's fine. A Kong gateway or an AI gateway can do that for you. But as the MCP server has to go out and communicate to an LLM, that same set of governance applies as well, because that traffic will go out, it'll be evaluated, the policies would be enforced, and effectively the models will return the data that they actually need to. And that's all I have for you. I tried to make it very, very quick, but one thing I do ask you all to do is maybe test out the AI gateway as well. I know John has been testing out a little while. He's very excited about the AI gateway technology. In fact, I built a workshop several months ago, and John's been doing it several times over, I think. Go head out to developer.konghq.com because one thing that we've really tried to do is improve upon the experience of workflows. So if you're trying to deploy something, trying to deploy the AI gateway, and you just don't want to be presented with a bunch of docs, but you actually need a natural flow that anyone can follow. Go check that out. And if you want access to this deck, it's right there for you. All right, thank you, everyone.